This is a recording over Algebra section 1.9, Inequalities and their graphs. And what an inequality means, or what it is the word in is a prefix for the word not, and so it's not equal. Okay, so it doesn't equal just one number. So how do I write and check and graph inequalities? Well, right here, these inequality symbols, we have the less than sign, greater than. When they have it under with a line underneath that is less than or equal to, or the word greater than or equal to. So what this means is like a scenario of like the speed limit. If the speed limit's 65 miles per hour, you can go less than or equal to the speed limit. This is an example of greater than or equal to. This is an example as if a sale or when you're shopping, $9.99 or like at what do I want to say? So probably price is starting. That would be a good one. Price is starting at $9.99. Okay, so that means it's either going to be $9.99 or greater. So that's what that symbol means. So I know a lot of people get messed up sometimes with these. Just think of this one, the less than, as like an L, and it's like squished. Then this one, I had people show me before to where it's the greater than, and they just like made a G for the greater. So if you're one that gets these confused, maybe those little tricks might help you. Okay, so when we write our inequality, we want to write the variable on the left side. So I'll explain a little bit more with that as we go along. So right here, what we're going to be doing is writing each sentence as an inequality. So the number W minus 3 is less than or equal to 2. So you want to look for your words that indicate the inequality symbol. So less than or equal to, well, that would match this one here. So we have W minus 3 is less than or equal to negative 2. And that's all we want to do there. All we're doing is just writing it. We're not solving it at all. This one, 3 is less than a number n plus 5. So less than, so 3 is less than n plus 5. Now, if you don't like it on this, like this, you can rewrite it to n plus 5, but you've got to flip your sign because this is saying the 3 is less than this. So that means n plus 5 is greater than 3. Okay. 0 is greater than or equal to twice the number x plus 1. So 0 is greater than or equal to twice a number x, so that's going to be 2x plus 1. Again, this one, you can switch it around to 2x plus 1. Flip your sign, is less than or equal to 0. Because if 0 is greater than or equal to it, that means 2x plus 1 is less than or equal to it. The number b is fewer than 30. So the number b is fewer than 30. If you're not for sure, fewer than, then look up in some keywords here. So fewer than. Negative 7 is at least twice the number k minus 4. Sometimes you have to read it twice. Negative 7. I don't know if I said negative 7. Negative 7 is at least twice a number k minus 4. Okay, so this one sometimes trips people up. I'm going to do this. Twice the number k minus 4. When you say at least, this means, a lot of people mess this up, that means it is greater than or equal to. That means that's the lower number. So you could rewrite it this way. Okay, so be careful with the words at least, and then careful with the words at most. Those are the two that most people switch around, so be careful with that one. Okay, so when we talk about a solution to an inequality, when we say, is that a solution to the inequality? It's the value that makes the inequality true. An inequality can have many solutions, and the set of all solutions of an inequality is called the solution set. Okay, so it's called a solution set. So here's an example. We just want to test to see if negative 6 is a solution to this inequality. X plus 5 is greater than or equal to negative 2. Well, you plug in negative 6 for x. Negative 6 plus 5 is negative 1. Is negative 1 greater than or equal to negative 2? Yes. Okay, so negative 6 is a solution to this inequality. Negative 7. Plug that in for x. Negative 7 plus 5 is greater than or equal to negative 2. Is that a true statement? Well, yes, because it's negative 2 is greater than or equal to. This does not say greater than and equal to. So this is greater than or equal to. Okay, and that's a yes. Plug in -8. -8 plus 5 is a -3, and that is not greater than -2, or greater than or equal to -2. So our solution set really starts at -7 and everything below it. So we're going to see if it works. Okay, so example 2, we're just testing to see. It says tell whether -4 is the solution to each inequality. So what you're going to do is you're going to put in -4 for 8, x. Sorry, early morning I'm doing this. -4 plus 8 is 4, and 4 is less than -3. Nope, that is false, so that is no. 4 is not a solution to this inequality set. I'm going to -4. Well, wait, hold on. The inequality is -4. -4, oh, it's still +4. Ooh, I had a mental breakdown there. Not really, but okay, I was still right. I was like, hold on, I was wrong. Okay, so -4. M is less than or equal to 3 minus M. 10. God, I need some water. 10, so I'm going to put a -4. Okay, be careful with this type of problem. It's 3 minus a -4. The M is a -4, so be careful and put parentheses around it because you don't want two signs right by each other. That's not mathematically correct. So you're going to have 10 is less than or equal to 3 minus a -4 means 3 plus 4, and 10 is less than or equal to 7. Well, that's false, so that's no. So -4 is not a solution to this inequality. Let's try this one. 4 times a -4 minus 25 is greater than -2. 4 times -4 is -16 minus 25. -16 minus 25, we're going further negative. So that's going to be a -41 greater than -2. False. So all of these are no. Okay. So none of these, -4 is not a solution to any of these. Okay, so now, since the inequality can represent a lot of numbers, we need to show a way that we can represent all of our solutions to an inequality. And we can do that by graphing. So we're representing inequalities by graphing. So if the symbol is less than or equal to, we use an open circle. And what we do on our number line is we plot the open circle on the point to where it can't go any further. And I believe this looks like it's hard for me to see, a -2. So we're saying here this x is less than -2. It's an open circle, and it has all the numbers less than -2. Greater than, we're saying x is, it's a -3, is greater than -3. So it'd be an open circle, and it would be going to the right, all the numbers greater than -3. This is less than or equal to. If it's less than or equal to or greater than or equal to, it's going to be a filled-in circle, meaning that number is part of the solution set. These numbers are not part of the solution set, but the number right next to it is. So we can't start with the next integer. We have to start on that line with an open circle because all those numbers between -3 and -2. So this one is saying x is less than or equal to 0. This one's saying x is greater than or equal to 4. This is just, it's so small for me to see. I had to look close. So what we're doing here is we're giving it inequality, and we're graphing it. So we have y is less than or equal to -3. So we're going to find -3 somewhere. There it is. It's a closed circle, and it's less than, so it's all the numbers less than that. X is greater than 0. Well, there's no equal or equal to, so it's an open circle. And then it is greater than, so all the numbers greater than x. This one, be careful. It's at 2, and we have an open circle. But this is saying 2 is less than x. Remember at the beginning when it said write with your variables on the left side? And this is why, because graphing, you got to be careful. This means the same thing as saying x is greater than 2. So be careful, because if the variable's on the other side, you might graph this incorrectly. But you're saying all the numbers greater than 2. And this one, b is greater than or equal to -8. -8, -8. Close circle. And everything greater than -8. So here's the deal. If you notice, some people start noticing that the arrow is pointing the same direction as your inequality sign. And that is true as long as your variable's on the left. You can rewrite these, that the variable's on the right, to match the variable on the left, but don't just switch the places. Make sure you reverse your sign also. Then your arrow here and your arrow here should be facing the same direction. Okay, so what this is saying, the graph shows a height restriction of h for 2 rides at a music park. Write the inequality that represents the height restriction of each ride. So we have one right here, and it looks like your height has to be greater than or equal to 48 inches. So think of Worlds of Fun, you guys. There's a lot of rides that you have to be measured to make sure you meet that height requirement. There's a lot of rides that if you're not 48 inches or above, you can't ride that ride. Okay, now check this one out. If your height is, now it's open circle, less than 52 inches. So you have to be less than 52 inches to ride certain rides. And think about it, Worlds of Fun, it's probably less than that really. At Worlds of Fun, it might not be, I can't remember, but there's a certain place at Worlds of Fun that you cannot be taller than 52 inches. I don't know if that number is accurate or not, but think about what that is. If you've gone to Worlds of Fun, you're right, Snoopyland. So at Snoopyland, it's for the younger kids. So they want the height restriction. Of course, the seats are smaller and they want just be enjoyable for the smaller kids. So just that's how the inequalities come into play in real life. All right, that is it for 1-9. Thank you.